Well, good afternoon. This is part 5 of what I think will be 6 parts of analog input, or the theremin. I'm going to add one more feature before we get to the final auto calibration of light intensity, and that is silencing the annoying squeal when it's not in use. The easiest way to do this is to detect when your hand is away and it's operating at data max, which is full brightness, and shut off the tone. We'll start it again when the data drops a little bit below data max by a small amount, meaning you must have put your hand over it, or perhaps the lights just went out. This particular segment has lots of talking, but it only really has 2 lines of code. Let me scroll my input slightly. Okay, to do this, number 1, we're going to use a classic if-then statement. Its structure, looking over on the left here, is the word if, try to highlight, the word if followed by a parentheses and a true-false test, followed then by matched braces containing a then this. There is no then keyword. It's assumed if something is true, whatever it follows it is going to be done. However, you can then go on to an optional else keyword. I'll underline this to show that it's a keyword. I'll underline the if to show that it's a keyword. And the optional else do that. I won't bother to underline those. Okay, so we said it had 3 parts. The if, the implied then, the else, and its curly braces in which you put the code. And all the code inside the curly braces needs semicolons as usual, but curly braces never have semicolons after them. Okay, so what are we going to do? Our if test will be to ask if the incoming data is slightly lower than data max. And how much lower, 2.1, is a matter of experimentation. You want it to be low enough that the theremin doesn't start up unexpectedly. Remember that the analog data bounces around by a little bit, but not so much lower that you lose a lot of tonal range. Based on experience and watching the bounce on my input data, I'm going to try 5 data units. Small, but I think it's sufficiently. It's probably kind of on the edge. So we're down here now, 2.2, 1, 2, third major indent. The statement is going to read if the incoming data is less than data max minus 5. Okay, the little caret, left caret, means less than, and the whole expression, A less than B, is true if A is less than B, numerically. And I'll put a list of the rest of these tests at the end. But an important thing to notice is that while numbers come into this test, A and B, the result is somewhat different. It's a truth value, which is a Boolean, or which has the values true or false, and it's not a number, although you can sneak numbers in, and I'll talk about that later. Also notice that the math, the data max minus 5, up here in our expression, first point, if data is less than data max minus 5, that the arithmetic, data max minus 5, is complete before the logical test is done. A little bit of trouble with the scrolling. Okay, we scroll up to the next point. So inside the then, meaning we've got a slight shadow, we'll have our usual tone command and its delay. We'll also have the else part, and this will call the no tone command to shut the tone off, because tone continues to run all by itself, just like PWM, if you don't do something else about it. So, point number 5, we're going to type this in now. If data is less than data max minus 5, then call the tone, speaker pin and frequency, delay for 20, all goes together into one piece. Here are the matching open and close curly braces, else, open curly brace, just do a no tone, no delay required, shuts it off. And where you put the open and close curly braces and the else is up to you. They can go on the same line or different lines. Arranging them this way is a fairly common standard. Okay, so let's give this a try. Scroll back up here to my point number 2. Let's go over to the right. We will start out with, this is going to be version 1.4. I've managed to resolve all the version and file numbering issues while we were all away. And it turns out that the version number is 1 less than the file number, and that's because my 1.0 started out as version 1, and 1.1 became version 2, and so on. So this one is going to be, what are we going to do? Replace numbers with variables was the last thing. This one will be silence, Theramin, if not in use, which means if the light is either too bright or, as we'll get to it, too dim. Because what happens when the light goes out? Well, it's just like having your hand over the thing. It's going to make noise. Okay, not good. So we're going to scroll down, and the only part that we're really interested in here is down here after we've gotten our data. So that's just before int freq over on the right. I'll highlight the line so you can see where I'm at. Okay, so we're going to add a new line of code after that. And it's going to be the if statement, see it turns red, open parentheses, and we would like to know if the incoming data is less than its maximum value, data max. It's always going to be less than data max, but minus 5, which means if the little region between 950, 949, 948, 947, 946, 945 is going to be ignored. All right, so, but if it's lower than that, open curly brace, and all we need to do is indent our frequency by 2, and our tone by 2, and our delay by 2. We're going to create frequency, and we're going to use it right here. Then we're going to put a close curly brace, and we're going to put our else, and we're going to put an open curly brace. This is what happens if the data incoming value is within 5 of the very top, and we're going to say no tone, open parentheses. We need to tell which pin, SPKR, pin, close parentheses for no tone, semicolon, close curly brace. All right, let's see if this compiles correctly. It does. All right, so let me plug my Theramin back in. It should start up. Yep, there it goes. Okay, let's upload this code. And we're done uploading, and it's quiet. So let's scroll down here saying, okay, we're giving this a try, and some time is going by. All right, let me put my hand in there. Oh, beautiful. Okay, bit of a shadow gives us some sound, and if I lower it, it goes all the way down. Goes all the way back up. I don't want to mess with my light too much because it's going to change the brightness, but I'll try. Okay, lights off, and the thing is humming. So that's still an issue. But lights on, we're golden. Okay, so what about my earlier comment, or just what we just discovered about the lights being too low? So it buzzes. We've just done that. Okay, let's use the same trick and make sure the Theramin data is slightly above the minimum too. And over here, number 8, we can ask the question this way. If the data is less than the maximum brightness and the data is also greater than the minimum brightness, then we want sound. The little right caret means greater than, and if A, right caret B, if A is greater than B, then it's true and something happens. And we're doing 2 different tests here. We're asking 2 questions. We're asking if data is less than data max, and we're asking if data is greater than data min. So we're going to need an and to connect these two questions together. And that is done with a little double ampersand, where A has some value true or false, B has some value true or false, and A double ampersand B is true only if both A and B are true. If one or the other is true, it's false. If they're both false, it's false. So our final result will look like this. I'll highlight it here. We're going to say if data is less than the max minus 5, and at the same time the data is also greater than the minimum plus 5. So the top down 5, the minimum up 5, then we would like to hear our tone. Okay, and we've left the frequency command out of my script there, but that's okay. We've got it over on the right. So moving over to my if statement, highlight it so you can see where I am. Okay, we're going to say and ampersand ampersand. Our data is greater than what? Data min, and not just data min, but data min plus 5. We're going to move it up by the same little minor margin that we moved it down by. Okay, not a big change, but it's going to be a big sound. The Theramin, capital T, Theramin, only if a hand is present, meaning comment, it is in a valid range of data. And so we have two valid ranges here, right? We had constrain, and that just meant that it didn't go totally wild. But now we're being a little pickier. We're saying, in addition to not going totally wild, we'd like it to be a little bit less than the biggest and a little bit more than the lowest. Okay, so let's go ahead and upload this and give it a try. It's compiling okay. It's still quiet because our bright silencer is working. Okay, there's my hand up close to the light. It's a high tone. I'm moving it down towards the photocell, and it's now close to the photocell or photoresistor, and it's shut off. And I'll turn off my light. You hear click, click, still quiet. Turn it on, still quiet. Put my hand in. Very excellent. Okay, so this bottom bit of code here is working perfectly. Data less than data max and data greater than data min. And in that case, do our whole frequency and our note time, which let me scroll up to the top. Yeah, it's sort of twittery. I'm going to put it back to 20 to smooth it out a little bit. That's the nice thing about having all your variables at the top. Okay, I'm going to save this, and let's see what else we can do. All right, point number 10. We've just tried that. Point number 11. Well, we still have perhaps, if you're going to be very picky, some lost notes, right? We're not running, if you look at map, we're mapping data from data min to data max to our frequency min to frequency max, but data never really gets as small as data min. It only gets to data min plus 5, and it only gets to data max minus 5. So we're not going to quite get our full desired frequency range, okay? So we can fix this by simply going in here and saying if the data is starting out at data min plus 5 and the data max only ever gets to data max minus 5, then those will be the proper numbers to match to our frequency range. You may not hear this at all, but I think that's technically correct. We'll upload it. We got to get a few more high notes. And a few more low notes, and I'm having to get a little bit closer to the photocell this time with that correction. But it should still go out if it should stop. Yep, no light. So I might rethink my 730 and maybe make it 740 given on my current lighting conditions. So let me go up to the top, 730. Let's move that up to 740 and require me to not get my hand quite so close to the photoresistor. Okay, let's give it a try. Still pretty close, 750. So this is why auto calibration is going to be a good thing. Move my Theramin up to 750. Well, still being kind of a problem about shutting off is not quite so bad. I'm now a couple inches above the photoresistor. Before I was virtually touching it. Okay, so we will save this as 5.